Hi, and welcome to today's Meeting C++ interview with Amar, who's written a book on embedded with C++. Let me quickly show you the book. This is the book which we're going to see in a minute. But first, let's get started with an introduction to know actually who Amar is.
Hi Jens, hi everyone. Jens, thank you for having me. I'm very much excited to be here, to be able to talk about my book. And I'd like to apologize to everyone for the delay. We had technical difficulties with this Bluetooth technology, but yeah, I hope I'm coming over well and you can hear me well. And yeah, I'm an embedded engineer for almost 10 years now. And uh, around 7 years ago, I started a small company in Bosnia and Herzegovina called Assembly, and we do a lot of interesting embedded projects. I started my career as almost any embedded developer using C language for programming these tiny devices. But soon enough, I figured out that C++ can be useful for what I'm doing, and I started applying it and using it in my projects. And yeah, that's shortly about me.
That's nice. And so today we are here to talk about this book, C++ and Embedded Systems, which Amar wrote, and it's a practical transition from C to modern C++. And that's very much true. So let's have a look into this book by going to the table of contents and just looking at the various chapters. There is various parts, 4 parts in total, and I think the book is useful for embedded developers, but generally if you're a C++ developer, the book is also still holding up. And as you know, the subtitle shows there's also some C code in here. So we have the first chapter starting with debunking some common myths about C++. And if we go into this chapter, we can see there's just an introduction into C++ and modern C++. And here we see like a first example that you can have an array as an std array, which I think is a nice example how to use modern C++ and to replace basic C types. And then we go on using algorithms, etc. So what's then, there's more and more and more. Let's go to chapter 2, challenges in embedded systems with limited resources. So we directly dive now into embedded systems, and that is more Amar's domain. So what is kind of your thoughts on the second chapter?
Here we discuss mainly challenges in safety critical and real-time systems with hard requirements. And 2 things that I often criticized in terms of C++ is that you can't use a standard library without dynamic memory allocation, which is not true, right? You need to be aware of containers that are using it and those that are not. But std array is a great example, and it brings just a lot in your daily life working with containers. Here we discuss that first, you can use also standard library and those parts that do not use dynamic allocation internally. The other part is discussing exceptions, as they are often criticized as being non-deterministic, meaning you can't predict that, how much time would something take, which is really important in systems with hard real-time requirements. But exceptions can be disabled, right? So you can't disable them, and you still can use C++ in your projects. Also, RTTI can be disabled, of course, and those are some of concerns of embedded developers. So you want to have deterministic, predictable systems, and here we focus on discussing how to mitigate those concerns. Right.
Right, here we go about disabling unwanted C++ features. And then we talk about the C++ ecosystem for embedded. And what does the book tell you about this?
Here we go through available toolchains from different vendors, and there's special accent on, if you're working with safety critical systems, then you need to use certified tools, right? And most of the tools are quite lagging in adopting the latest standards. So at the time of writing the book, majority of tools that offer certified compilers provide you with C++ 17, right? And the book was written mostly last year. So that's an issue for people that are working on critical systems. And yeah, they are basically bound to using nowadays C++ 17 um, if they want to comply with the regulations. All right. Still, if you're not working on something that's safety critical, you can use GCC supports the latest standards and plan as well, so you can use those, right? Beside this, we also briefly discussed these other useful things such as static analyzers,
Unit testing.
utilities for unit testing, and a bit profiling. Profiling is interesting in the context of the embedded development, as you can't really use the tools that you can on your desktop machines, right? Because you need to interact with embedded target. Still, there's plenty of options for that as well, and I'm suggesting just a few that might be useful for people. It's not really specific to C++. It's just, in general, whether you're writing code in C or C++ or whatsoever, profiling is important, and we just briefly discussed the process there.
Indeed. Then we follow up with setting up the development environment for an embedded C++ project. What's kind of the environment you use for the book?
So there we set up environment using VS Code as the editor or the IDE, right? We are using CMake for build system, and we are using GCC compiler. On top of that, we are using Renode simulator to run the firmware in the simulation. So anyone who's reading book will get access to the Docker container that has all of these tools contained. And all you really need to do is set up the Docker, run the container, and you have access to the tool chain and everything you need to run the examples in a simulator. You can still run the programs on the target, if you will, but for that you would need a development board, and you need to flash the binary to a target, right?
Yeah. So we spoke a bit before the interview about that the book is basically set up that you can run everything without having the needed hardware. But if you have the hardware and if you have the experience already, then you can try out then the code is also tested on definitely on embedded platforms. And now again, chapter 5, we go back to C++ now and discuss the building blocks of C++ applications with classes. Yeah.
So this chapter 5 and chapter 6, I believe, are used as either starting point from someone who's coming from C and doesn't really have a lot of knowledge and experience about C++, or even for people who do have some knowledge about C++, I think some of these parts may be useful. So we discuss in this one mainly classes, initialization, and similar things.
Yeah, I see here in chapter 6, you're now going into namespaces, function overloading, interoperability with C, references, and standard library containers and algorithms, which makes a lot of sense to give people an introduction to those parts of the language if they're coming from C or if they need a refresher on that, which, that's our audience. Then we are again diving back into the firmware and embedded space with the 7th chapter on strengthening firmware, practical C++ error handling methods. And here we mainly talk about error handling. Here now actually also is a part with exceptions, which I remember from the book. So
we discuss here the common methodologies of handling the firmware in C code, and that's through the error codes, right? So C is mainly limited to that. You can also use things such as global error handlers and such. And after discussing those and showing people how they can use these in C++, we also cover exceptions here. To some extent, also we show them how they can override the terminator, default terminator, and use that if they will. And we also cover things such as stud optional, which is not really used for error handling. Kind of is, if you have, let's say, a function or method that returns some data from a sensor. It can return data, but it can also return nothing as data is not ready for some reason. So stud optional is useful in those scenarios in the context of the embedded development. And of course, we cover stud expected as one of the methodologies for handling errors.
Yeah, and that's also basically what the standard now has to offer in this regard. Then we move on to the 8th chapter, when we actually also now get into templates and concepts. So we have a bit more advanced C++ features here in the book covered now.
Yeah. So we cover basics of templates and metaprogramming there, starting with the example of simple calculations and how you can do them at compile time, and also showing the equivalent with constexpr. And we also cover here Finite, basics of template metaprogramming. And we also touch a bit CRTP as compile time polymorphism pattern, right? These things are briefly covered. Templates and everything related to templates is just a huge field, and people are writing books just on these topics. But the intention of this chapter is to give reader introduction to templates. This is by no any means a full guide or whatsoever for templates, but I think it serves well for introducing people to templates and applications of templates in the code.
Yeah, I think that if you write a book about like applying C++ into a field like embedded, you can't have like also include the full language. Like everything about templates is a book on its own.
Yeah.
And then we get into using some of those features to build strong types and use type safety, which I think is, and again, one of the things which where C++ shines in contrast to C and embedded, when you actually can have some of the calculations which otherwise would be at runtime. Yeah, on compile
So
time and on checks.
yeah, so we cover implicit conversions in C++ and also explicit one in this chapter, and then we move to strong types. And I used as an example a function from a C library provided by vendor. It's part of BLE stack on one of the platforms that I worked on, and basically we show how we can use strong types to, let's say, fix some of the flows of this function. It's a function with a bunch of parameters. Yeah, that's one, and most of them are UN16, and most of those parameters are some kind of time intervals, but they are all treated differently. So they are using a couple of different macros for those arguments, and it's quite easy to swap those macros and to use wrong one. And here we show how we can wrap this simple C function in a C++ to use strong types. So if you actually swap those previously macros, now types, the compiler wouldn't. The compile would fail, and compiler would alert you that you are using actually wrong type. Yeah. So I
Yeah,
think
that's
yeah. Yeah.
Then we are in chapter 10, where the book is then going into expressing, writing expressive code with lambdas. Yeah, I think lambdas in general are a great use case, and generally making it's a great feature.
Yeah, yeah. I mean, if you just take, take as an example any C function that expects a some kind of callback or similar, and you are scrolling through code and you see that function accepts some callback, and you're interested in that functionality, then you need either to change file or scroll somewhere and see what's going on, right? But Lambda allows you to capture that functionality in a place that's close to the call site. So that's one of the applications which just adds to readability and to expressiveness of the code, right?
That is true. And yeah, I like that you're also then showing people that std function can be used with lambdas, and then you're using it here for GPIO ports. And so the book has not always, but in some chapters, I've seen these nice UML graphs, which I really like. Makes it kind of more graphical to people what is happening. And here's another example.
So that's basically a, let's call it GPI interrupt manager. So on a microcontroller, you have a bunch of pins, and some of them you may be using, let's say, as buttons. So what we do in that example is show you how to tie interrupt that are coming from those buttons to functionality that you provide to those objects through lambdas. And yeah, I think it's something, let's say, different to what folks in C world are seeing, and I use that as an example to show how you can use lambdas.
Yeah, I think this is a very useful feature, also showing how to apply it to an embedded problem domain. And then we return to the whole compile time domain and use it for computation.
Yeah. Well, the const expert is just one of my favorite features, and compile time computations in general, right? So here we show we gently guide reader through an example which shows them how they can build a utility which allows them to calculate really complex signals at compile time. And
Mhm.
if you scroll down, there is this huge formula that we are using as a um, table for temperature sensor, which allows you to get, yeah, it's that one.
This Yeah,
If you scroll
I noticed
up a
when I
bit,
scroll up that you had
yeah,
here
yeah,
as the first example a MAC address parser,
yeah, yeah,
which I
yeah,
think MAC addresses are generally parsing addresses and strings at
yeah,
compile
yeah.
time, catching
So
errors.
that
Interesting.
right, that allows you to enter the MAC address in human readable string. Yeah, and as you said, it allows you to parse it to uh, an array, and it allows you to catch an error there, right? So those
Mhm.
are two functionalities that this piece of code is giving us. One, to capture those kind of errors, and the second one is it converts this string, which is human readable, to just 6 bytes in an array at compile time. So nothing is executed in runtime, and everything happens at runtime, at compile time,
Yeah,
right?
indeed. And then the second example is the lookup table which you mentioned, and this is the
Yeah,
example here. Um,
yeah,
we build a struct signal, and
yes.
yeah, that looks interesting. Um, and here we are in the generating code then at compile time. That is, I think, that's why I think it's like, it applies to the embedded domain, but also like if you're just generally doing C++ and you're naturally probably interested in also having some embedded knowledge, the book works really well in that demand. Then we have a chapter about writing C++ hell, so the
Uh-huh.
hardware abstraction layer, which
Yeah,
again, we're back into embedded, right?
yeah. Here we see how, most of the not most, all of the peripherals on modern microcontrollers are basically memory mapped, meaning that if you want to set up a GPIO, you just write something in a piece of memory, which in returns sets up and configures a register which is handling that peripheral. So there we see how we do it in C, and afterwards we go through a bit of uh, template magic to see how we can strengthen that in C++, and to have all those compile time checks. So there are registers with some bit fields, and what we want to do is to know exactly at compile time which bit field are we setting up, which value are we writing to it. And in C, you can write basically anything at that memory address. Nothing's going to stop you. But with utility as this one, we are strengthening that, and we are getting those compile time checks, which are which allows us to write in a bit field only valid values, right? And
Yeah.
all of that for we don't pay any price in terms of additional binary size or additional computations at runtime, as everything is being done at compile time.
Yeah, and then you go into timers, um, which is again is something which you can set up at compile time and then have
Yeah,
be checked for being correct and adding up to things that make sense.
right.
And that brings us to chapter 13, which is working with C libraries, which of course that's like also every day we interface with C and C++.
Right.
So
Um,
this
uh, yeah,
yeah.
we show there how we can wrap let's say, C HAL in C++ in order to make a piece of code platform independent or hardware independent. So, for an example, we can have some kind of uh, we can have, let's say, accelerometer class, which is specific to a certain accelerometer. And in order to communicate with that accelerometer, we need to use, let's say, I2C interface. So what we can do for that accelerometer, we can write a class that depends on a I2C interface, which is a wrapper for actual implementation for specific hardware platform. And it basically shows you that, right, how to decouple things and how to use C++ for that. The same can be done, of course, in C, and this is just more about the actual approach in the development itself.
And
Also, yeah, of course, we are using RAII there with an example of a file system. So LFS is a small file system for microcontrollers, and there we show how we can use RAII to, if we open a file, we actually access the file system and open it, and in this structure we are closing the file. So resource acquisition is initialization. So we apply that principle on an example of a file system.
yeah, I mean that's just a classic pattern how you
Yeah.
make the code better.
Right.
Also implementers and everyone on the team will then have a better time to access that library. Then we're going to enhance super loop with sequencer. That's now something where I'm kind of have some question marks on my face. What is this chapter about?
Yeah, so a super loop is, let's say, the most basic bare metal architecture there is. So that's a great example. You have main with while loop, and you have a bunch of flags there, and those flags are set from the interrupts, right? And all that main function is doing is going through those flags, see if they are set. If they are set, it will do something, reset the flag, and do that infinitely. And that's the most basic thing you can do. Then we introduce a sequencer, which basically allows you to store those, let's call them tasks. They are basically functions, but let's call them tasks. You can store a task in a sequencer, and sequencer you can define different priorities for tasks, right? Something that's impossible with those initial approach with flags. You can also introduce priorities there, but all it's going to happen is you're going to end up in spaghetti code, right? So basically, sequencers is solving those problems for you. It allows you to add tasks to it, and in returns, it executes those tasks for you. So we go there through how to actually store a task, and task can be given as a lambda. One of the options is to use stud functional, and we also have their alternative. There's a utility from ETL library, embedded template library, and they have equivalents to stud function, which are not using dynamic memory allocation, which is something that's important for a lot of embedded people. So I use that opportunity to introduce it and to show it how it can be used, right? The other thing we do there is introducing stud priority queue, and we provide it with, I believe, stud not stud vector, but ETL vector. And ETL vector is vector from embedded template library. It has the same interface as stud vector. The only difference is that once you initialize it, you give it size. It has fixed size, so you can think about it as a fixed size vector, which is also important for embedded people, as they're going to be certain that there's no dynamic memory allocation and such, right?
Yeah, that's interesting, and especially that there's a domain-specific library which also kind of has types which are similar to the modern C++ focused standard
Yeah,
library.
and that allows you to use them in stud algorithms, for example, or even in this example, you can use stud priority queue and provide it with this ETL vector or whatsoever. So it shows you how you can still use the stud library with let's call this embedded template library. So the ETL is kind of complementary to the standard library. I'd say that way.
And then we talk about patterns in the 15th chapter. Building a temperature publisher, which is also like something which is like a very big problem, which project I wanted to say, which a lot of people do.
Yeah, we go there to an example of publisher or observer pattern, and we go through the boot runtime and compile time implementation of the pattern. There is an example of how to use parameter pack to provide it with all those subscribers, and in turn you have something that has minimum memory footprint, and it just wire, let's say wire really nicely those things for you. This is something that's often used in the embedded systems. You can grab data from a sensor, and you need that data in different places. You want to show it on display, you want to send it to server, you want to log that data, and what you can do is just subscribe to a publisher who's offering that data, and then do with that data whatever you want, right?
And then we move on in chapter 16 to finite state machines. And I think
please go ahead. Sorry for
I generally think that state machines definitely have their place in such a book. So I really like that chapter 16 goes into state machines and embedded. Here we have another UML diagram.
They are really used often in different places for from controlling an elevator to controlling the state of BLE controller. And here we're using the example of BLE controller, which can be in a couple of different states. It can be advertising, it can be connected, it can be in idle state. But the example is really simplified, and it guides you just through a couple of different implementations of an FSM using state pattern. And at the end, we are introducing Boost SML, which is really great library, which allows you to define your state machine in really expressive way. And yet again, it has minimum footprint as it is doing a lot of event dispatching at compile time. So it has great performance and minimum memory footprint, and it allows you to write really complex state machines.
Interesting. Then the 17th chapter, you talk about libraries and frameworks. And here we now have the standard library again. We already talked a bit about the embedded template library, and then there's Pigroot.
Standard library and embedded library were used a lot in previous chapters, and this is just like an overview. And here we introduce two interesting projects. One is Google's Pigweed, which is kind of an entire framework for the embedded development, and it does a lot of heavy lifting for you. So it's quite an interesting thing that people can go through this simple basic example and see what it offers. And here we are using RPC, a remote procedure call feature that it offers, and it shows you how you can trigger certain actions on your target from a Python console. And this is quite useful for two things in the context of the embedded system. One is while you're doing development, you occasionally want to test some functionality on target. And if you are working with really complex embedded systems, you want to be able to trigger that behavior immediately without waiting to go through certain scenarios or whatsoever. So the RPC allows you that, so you can trigger certain function call or functionality on your target from a console. And that's something that's also useful during manufacturing. So if you're manufacturing a device, you want to be able to test it, and there are entire scenarios for testing devices during the manufacturing process, and you need a way to trigger certain behaviors. So this is something that's quite interesting in that regard. And the other, yeah.
I think like this, then like the next chapter already moves into this like cross-platform development, and when you manufacture things that you need to be able to not only like test your code on the embedded platform, but also have the ability to test there, because some bugs will only show there.
Of course, yeah. Right, as you said, the entire book is stressing out the importance of hardware independent code, which allows you to test that code, to test the business logic, to have the unit tests. And this chapter just wraps up that story about the software development in general, right, with the accent on C++ and the embedded systems, right?
Yeah, and yeah, I think that's then kind of the book closes out on testability, and here the summary. Okay, so let's get started with the interview then. That has been the book overview. It's with 17 chapters. It's really covering a lot of ground about C++, but also about embedded. And then let's see, to the audience, just if you have questions, then post them to the chat. And I, of course, have some questions prepared. So generally, we're in the embedded space, so maybe let's start with that. What embedded hardware have you used to test the code and run the code on for the book?
So the code is using the STM32F071 target, but you don't need actual development kit in order to be able to run the code, as you can download Docker container, which has the entire tool chain prepared for you, and it also has a Renode simulator, which allows you to run compiled code in the simulator, right? So you can also, if you want, you can run the code. You can flash your target with the firmware, but in general, if you are reading the book, you don't need the development board at all.
Indeed. So I think it's fairly clear for which this audience the book is. But like, let's take for a minute with C++. What standards have you used or mostly used in the book?
The book covers features from standards up to C++ 23.
Mm-hmm. Yeah,
And
I've seen versions of 23, but I know a lot of developers are still on 17, and now we're moving on to newer features, so the book has that covered. That was also my impression. Let's go into some of the audience questions. So Lizio asks, why don't you use STL containers with specialized allocators?
Yeah, that's also an option, right? I haven't tried to write a specialized allocator. To be honest, I think that's quite challenging to get it right, to guarantee the execution time, which is something that's also important in regards of the real-time embedded systems. You want to be sure that the allocation would always take a certain amount of time, right? Uh, Still, yeah, that's a possibility. But ETL, embedded template library, is an alternative for the containers.
Yeah, and I think one thing one always has to see is that the space in a book is limited. So going into such corners as how to specialize allocators for embedded um, might be then a bit too much. Which actually brings me to a question like, we see a lot of chapters in the book, but like what topics didn't make it?
Oh yeah, I'd say a lot. Things such as bitset is not in the book. Some of the examples I initially had in mind that could have been more visually appealing to people are not there. So one of the ideas I had is 7 segment display, and it didn't end in the book. And yeah, there's quite a few things that are not there. So by no any means this is not a complete guide uh, for the C++ in embedded systems. It is, let's call it, missing a lot of things. I wish they were there, but I was limited by time, and if you'd put everything in a book, it would be really, really, a really big book, right?
Indeed. Do you have plans like for a follow-up book? Do you,
I'm not sure. Let's see how this goes. Let's see how the reception from the people is. The book was published on 2nd of July, so that was like 15 days ago. So in uh, following months, I expect to receive more feedback from people who read the book, and I guess that everything will depend on that. If the book is accepted well, then yeah, why not?
Mhm. Yeah, that's maybe something we should mention that the book is kind of new. And
Yeah.
um, so Belizio has a second question.
Yes.
How can you be sure that an SCD function doesn't allocate memory while storing lambdas?
One of the things to do is to override new and delete operators and just to monitor them and see if they're being called by anything. And that's just one of the ways to make sure that no one is trying to do any memory allocation. But if you want to be 100% certain, then just avoid it, right?
Yeah, I think that especially like you bring up the ETL in this context that that they offer the type which doesn't allocate.
Yeah.
And on the other hand, I think with lambdas you're on the safe side when you're using function. But I've had also some pitfalls with function and copying them, etc. Um, so there's another question: do you plan to create an online course with the topics from the book?
No, not really. I don't have any plans, to be honest, at the moment.
Okay. Um, then how does this book help you to write better C++ code?
Hmm. The intention of the book is to introduce C++ to people who are mainly using C in their daily work, and I did the best of my ability to write a good and well-structured C++ code. Maybe I failed at some parts, and if you have any, you know, criticism on some portions of it, please let me know.
So I think that the book probably reflects your own style and what you do on your company, how you
Yep.
do your projects there. So, what did you learn about C++ while writing the book?
This is a tough one. I had to explore some portions uh, of what I was already applying, and I was taking some things for granted that I discovered later on that are perhaps a bit different. And uh, one of them is mostly related to the standard library. So the one that's being used is uh, based on nano standard library, and there are just a few different ways to compile that library with or without exceptions, and in turn you end up with uh, quite a big difference in terms of the memory consumptions. And it turns out that the exceptions in this implementation are quite expensive. I haven't spent more time uh, digging out, about exceptions and seeing if there's any better implementation. So that's one of the things that I'm quite interested in. And yeah, once I have some more time, that's something that I'd like to explore further. So by the time of writing book, I wasn't even considering using exceptions, and in one of the chapters I wrote about them, and only then I saw how big portion uh, of the flash they actually take. Uh, Perhaps it's implementation specific, perhaps the library itself can be compiled a bit differently to still have exceptions and uh, to reduce that size. So that's one of the things that surprised me a bit.
Yeah, so I think that with the embedded audience, exceptions are not too popular, but
Yeah, that's
the
that's quite correct.
the the question in the recent years always has become like what kind of embedded are you working on? And systems have grown, and there's definitely some space for where exceptions could make sense. Um, Outside of that, you probably have this code then shared across your platform, and then maybe that's not making sense anymore.
Mm.
But so one topic which I saw, which has been very important in the last decade in C++ generally, is like the exploration of multi-threaded code. And I wonder
Mhm.
just, how is that being seen in the embedded world?
So the most of the projects that I worked on are still utilizing FreeRTOS, which has the threads or tasks as they called, and in certain applications it's actually used quite a lot. I didn't have a chance to use C++ in those kinds of environment in last year or so. I've been mostly working with C on projects for our clients. Uh, but yeah, multi-threaded code is used quite a lot, especially on a big and complex systems.
Okay. So just to the audience, if you have any more questions, now is kind of the time to add them to the chat. There is probably like when we talk about embedded, and the book covers a bit of safety, we should talk about Rust. Do you see Rust in the embedded space? Is that something which is coming up?
I see a lot of people talking about it, and I see certain companies are started adopting it. Uh, so yeah, I'm seeing Rust getting its way into the embedded. Uh, last year and a half or so, I was pretty much occupied with writing the book, so I didn't really had a chance to explore Rust more, but I got the basic premises of it, the borrow checker, and what it offers in terms of type and memory safety, and those things are always welcomed in the embedded systems, especially those that are safety critical. Yeah, I definitely see Rust having its place in the embedded.
All right, and there's also a question and comment which I see on LinkedIn, but it doesn't show up here in the local studio. So let me quickly copy that into a banner, and then I can show it here. So while we are at the topic of Rust, so these days are, they are exploring ways of using Rust Lang in our code for C++. What are your thoughts about mixing Rust Lang with C++ for dedicated modules written in Rust, for example?
To be honest, I don't have a hands-on experience on Rust or on mixing these two, but if Rust is solving a problem for you and you want to use that as a module in C++ or vice versa, I don't see any reasons against that. Both Rust and C++ are tools in our world, so using the right tool for the right problem is most certainly welcomed, right? So if you see that a good fit, then go for it.
Yeah, I think the interoperability of Rust and C++ is something which some people explore currently. And
Yeah.
for example, at CS Meeting C++, we have one talk about that. I know that the KAB is exploring it in the context of doing Rust with Qt. And so there's definitely areas where you find information about that. But then again, it's like when you do embed it with C++, and your everyday work is like C and C++, then it's hard to find like actually someone to pay for your time to go into Rust and to figure out what the best way is to connect that. So I hope that we get a better way of having this standardized and become part of our world. And that brings us pretty much to the end. I think I have no more questions. It's a very interesting book. Thank you for taking your time and taking the time to write this book and sharing your own knowledge with us, which is very interesting in this book, definitely. And I see that at least one person has bought the book already. So thank you, Florian. And
thank you very much.
With that, Amar, final words.
Yeah, I might be biased as I love C++. I really that's something that I really enjoy. So this is me being completely biased, right? And yeah, I just think it's great for the embedded systems. And if you would like to actually see what it can do for you, then read the book, right? But this is a completely biased opinion of mine.
Yeah, I mean, it's. I think we're on the same page there. I'm also a bit biased towards C++, and I think the audience that we reach is too. But generally, interesting topic today, and lots of interests. Saw a lot of people in the chat and also in the stream on LinkedIn. And if you made it so far, a recording will be out on Saturday. Anyways, thank you for your time, and I'm going.
Thank you, Jens. Thank you so much.
You're welcome. Also, last but not least, thank you to Peg for providing the book and making this possible.
Yeah, of course.